In this project, I will demonstrate how to use custom bootloader for FPV RA0E1 board. Open ESK Studio and click on Import Project button. Then select the option to import existing project from the workplace. Now select the option to import from root directory, then press Browse button. Now navigate to the folder where example bootloader project is present. Select the bootloader root directory, then click on Select button. Now in ESK Studio dialog box, bootloader project is imported. Now click on Finish button. In this example, I will utilize two projects. First project is the bootloader one we just imported in ESK Studio. Other is a sample project to be uploaded via custom bootloader on FPV RA0E1 board. Import the sample project in ESK Studio, then click on Finish button. In Project Explorer tab, expand bootloader project, then open FSP configuration file. If you have latest FSP version, you can click on Continue. Otherwise, you need to install the FSP version on which this project is created. Now click on Stack tab, then click on UART stack, then open its properties. Here you can study the pin used for UART A stack, then the baud rate. This project is using P100 and P101 for UART stack, and the baud rate for the project is 115200. After that, you can click on Generate Project Contents. Now click on bootloader project name, then click on this hammer icon to build this project. If you want to study the memory region used in this custom bootloader project, you can open script folder, then open memory region file. Here we have mentioned some addresses for the memory region and the memory section used for custom bootloader project. We are using 32 kilobyte for the custom bootloader project. We can use next 32 kilobyte flash memory region for user applications. The memory region file is also present in debug folder. Now right click on bootloader project, then select debug as, then select Renesas GDB hardware debugging. Now click on switch button to switch to debug perspective. In debug perspective, click on this resume button twice, then press this terminate button. Now click on C++ button to open C++ perspective. Now open RA0 app project, then click on continue button. This is a simple application project which will turn on the LED after custom bootloader has written the user application on FPV RA0E1 board. Now click on app project name, then click on this hammer icon to build this project. After a successful build, if you expand debug folder, you can observe there is .bin file here. We will use this bin file to update the user application on FPV RA0E1 board using USB to UART converter. To generate binary file, right click on your project name, then click on properties. Now expand C++ build, then open settings. Now open optimization option. For optimization level, here select optimize aggressively for size -OZ. Now click on GNU ARM cross create file image option, then click on general. Here select raw binary option to create binary file. Now click on apply and close. Now if you build your project, binary file will be created in debug folder. Now we can read quick start guide document for board layout and pin diagram. According to this document, P101 and P100 is connected with D4 and D5 of Arduino interface. After bootloader project is running on FPV RA0E1 board, you can open Teraterm software. In Teraterm software, click on setup, then click on serial port. Here you can select correct baud rate according to our project. After selecting correct option, you can click on new setting option. Now if you press the reset button on FPV RA0E1 board, a menu will be shown on Teraterm screen. Now press 2, then press enter button. Now in Teraterm software, click on file, then click on transfer, then click on XModem, then click on send button. Now a dialog box will appear. You can select .bin file for user application. After the transfer is successful, we can observe that LED 1 is turned off and LED 2 is turned on. This indicates that the new user application is written on flash.